Today we're going to learn how to simplify square roots of numbers that are not perfect squares. So when we have a number like square root of 75, if we type that in our calculator and get square root of 75, it's not going to be a nice number. If we typed in like square root of 25, it'd be beautiful. Square root of 25 would actually be just 5, but square root of 75 is ugly. So when we think about square rooting a non-perfect square like 75, we can think about it as square rooting two numbers. Square rooting 75 is kind of like the square root of 3 times 25. Now, we know how to square root 25. Square root of 25, since 25 is a perfect square, we know that the square root of 25 is what? Well, if we type that in our calculator, we get 5. But the square root of 3 is ugly. It would actually give us something like 1 point something ugly. I don't even know. It's irrational. It goes on forever. So when we do this, we're just going to write them in simplest radical form, which means not as a decimal, but anything that doesn't come out nice, we're going to leave it underneath the square root, which means our answer for the square root of 75 is 5 times the square root of 3, 5 square root 3. Because we know that 75 is 3 times 25, and 25 square roots nicely. So we went ahead and square rooted the part that came out nice and left the ugly part inside the radical. Okay, so let's look at another example. Number 2, this is another one that has a 5 on it. So if we think about the factors of 45, that would be like 9 and 5. And then we could square root 9 and square root 5, but square root of 9 comes out nice, and square root of 5 comes out ugly. It comes out as an ugly decimal. So our answer, we're just going to square root the part we can and leave the part that we can't. And we do this using factor pairs. So I went through those very quickly. Let's look at another couple examples. These are a little bit different. You see we have square root of 45 in number 3, except it says 2 square root of 45. So there's already a 2 out there. So if I were to do what I just did and break that down in 9 times 5, square root of 45 is 9 times 5. So that means I can get a 3 and a square root of 5. But let's not forget that we already had a 2 out there. 2 times 3 times square root of 5. So we end up combining those that were already are on the outside together. We end up with 6 times the square root of 5. So this relies on you being able to pull out factors. Now, I could do this as 5 and 10, but the problem is 5 and 10 are not pretty, right? Both of those are going to square root to ugly. So what we want to think about when we're trying to think of factor pairs is we want to think of factor pairs that are perfect squares. So we're thinking of 4, 9, 16, 25, 36, 49, all of the perfect squares, because we know that all of those square root to a beautiful whole number. So when we do this one, if we do 10 and 5, neither of those numbers are pretty. But you can see that we could do 25, because 25 is pretty when we square root it. And then we could do 25 times 2 gives us 50. So we can use 25 and 2. What this allows us to do is then have the square root of 25 to come out to be just 5. Square root of 2 is still ugly, so it's square root of 2. We already had a 7 on the outside, so we have to do 7 times 5, and we get 35 square root 2. Five and 6, these numbers are pretty small, so hopefully we can kind of see what's happening here. I can take a 4 out of this one, and I can take a 4 times 3. Okay, well, 4 times 3 gives me 12. So the square root of 4 times the square root of 3 is going to give me the square root of 12. I'm going to go ahead and bring down my 4 as I go so I don't forget it. On the outside, the square root of 4 is 2. So now I have 4 times 2 times the square root of 3. So I multiply the two parts that are on the outside, and I get 8 square root 3. Let's look at square root of 63. There's nothing on the outside. I got to try to break this down. At first, I'm thinking maybe 3 and 21, but that doesn't seem to work. because neither of those are going to square root nicely. Are there any perfect squares that go into 63? Well, if I can't come up with them off the top of my head, I can simply list them out. I think 4, and then we have, what else? What's another perfect square? 4 is 2 squared, so 3 squared is 9, 4 squared is 16, then 5 squared is 25, 36, 49, and then we get up to 64. So obviously I know that 64 is not going to work. 49 doesn't divide evenly. 63 is not quite half. 25 doesn't work. 16 doesn't work. So 9, what about 9? 9 times 7. So what's the square root of 9? That's 3. And the square root of 7, it's square root of 7. It doesn't come out nice. So we leave it and we're done. So I kind of work my way through those perfect squares to find one that is going to give me a nice number here. So now as our numbers get a little bit bigger, I'm going to do the same thing actually. I'm going to write down the 4, 9, 16, 25, 36, 49, 64, and that's 8 squared, so 9 squared would be 81. Okay, well, none of those are obviously exactly 147, but do any of them factor in? So what I can start to do is I start to eliminate. I do 147, and I look at the biggest number I can think of. Does 81 divide into 147? And if I do my division, it doesn't work. It comes out to a decimal. 64 doesn't work. I type that in. 49 actually does work. 49 works. And so if I do 49, I get 49, and my remainder is 3. So I do 147 divided by 49, and I get 3. So I can square root both of those. I still have that 8 on the outside. The square root of 49 is 7. And the square root of 3 is ugly, so it's square root of 3. 8 times 7 is 56. Square root of 3. And that's done. When we look at this next one, I can look for 81, 64, but again, 49 works. 49 works again. So I have 49 times 2 this time. And I have my 3 on the outside. And I end up with 3 times 7 times square root of 2. So that's 21 square root 2.